We need to evaluate this integral having this integrand over the circle C, where C is the circle mod z minus 1 equal to 3. It is the circle having the center at z equal to 1, and it is having the radius 3. The next step is to find the singular point. And how to find the singular points? By taking this denominator equal to 0. So z equal to negative 1 is a singular point and is having a pole of order 2. Because the power is 2 here, so it is a pole of order 2. Right? And now we need to check whether z equal to negative 1, this point lies inside the circle or not. If the point lies inside the circle, then we calculate the residue of fz at this point. What is fz? We take our fz to be this integrand. Right? So we find the residue of fz at the singular point which is lying inside the circle, and then by applying the residue theorem we evaluate this integral. Right? Let's start with the solution. So we have taken fz to be the integrand, right? And now we need to find the singular points. How to find the singular points? By taking the denominator equal to 0. So we get z plus 1 equal to 0. That is z equal to negative 1, which is a pole of order 2. So it is a pole of order 2. Right? And now we need to check whether this point is lying inside the given circle or not. Let's check this. The circle is centered at z equal to 1 here, right? And it is having the radius 3. So up to negative 2 and 4, right? Please consider this to be your circle. I know it's not a circle, but consider this to be the circle mod z minus 1 equal to 3. Is the point negative 1 lying inside the circle? Yes, the point negative 1 lies inside the circle, right? So now we need to calculate the residue at this point. So the residue of fz at z equal to negative 1. What is the formula for calculating the residue of fz at a? So that is 1 divided by m minus 1 factorial, limit z tending to a, dm minus 1 dz m minus 1, that is derivating the function m minus 1th times z minus a the power m f of z. Please remember this formula, where this m represents the pole of order. Right? In our example, the pole is of order 2. So we take here m equal to 2, and now calculating the residue. So just put the value over here. 1 divided by 2 minus 1, that is 1 factorial. Then limit z tending to a is negative 1. Then the derivative m minus 1th time, that is 2 minus 1. We have to derivate only once with respect to z, and z minus a. A is negative 1, so it is minus 1, which becomes z plus 1, and the power m, that is 2. F of z. What is f of z? E the power z divided by z plus 1 whole square. Right? So this is equal to limit z tending to negative 1, taking the derivative of these two cancelled out, e the power z remains only, and is equal to limit z tends to negative 1, derivating e the power z with respect to z, it gives e the power z, and putting z equal to negative 1 we get e the power minus 1, or it is 1 divided by e. And now we are going to apply the residue theorem to evaluate the integral. So by residue theorem, the given integral is equal to 2 pi iota times the residue of fz at z equal to -1. Please remember, if we have more than 1 points lying inside the circle, and then just take the sum of these residues and take all this sum inside this bracket. You have to take the sum of the residues inside the bracket, right? But here, because we have only one singular point, so we have calculated only one residue at that point. Okay, what is the residue we have calculated? It is 1 divided by e. So this is 1 divided by e. So 2 pi iota divided by e is the required solution. Okay, thank you.